Ladies and gentlemen, lesson 5.5, solve and check equations, x plus a equals b. Your learning targets for today for this lesson are to be able to identify equations of the form x plus a equals b, and then also to be able to use the addition property of equality. We'll spend a little bit more time in class on examples of solving. So let's dive right in. This is our warm-up. This is our warm-up. Definitions, notes, and examples. I'm going to ask you to give a solution for each equation below, in equations 1, 2, 3, and 4. Just a quick reminder, in case you've forgotten, equation is any math sentence with an equal sign. The solution is the value of the variable that makes the sentence true. Go ahead, press pause, and hopefully solve out each of these equations. In number 1, hopefully you found that x equals 2. In number 2, hopefully you found that y equals 16. In number 3, hopefully you found c equals 13. And in number 4, hopefully you found that h equals -9. If you did not find the correct solution for x, y, c, and h in 1, 2, 3, and 4, during today's lesson we will be talking about different methods that we have that can help us solve an equation if it's not quite as obvious. Number 1 was intended to be a little bit obvious. So taking a look, equations of the form x plus a equals b. This is any equation with addition or subtraction, which can be changed into addition, is the only operation. It must contain a variable. Each of the examples that we saw in the warm-up, each of the equations in the warm-up were all examples of this. Go ahead and write 2 more below. Remember, a variable plus a number on one side of the equal sign and a value on the other side of the equal sign. Next, we're going to talk a little bit more about equations in our addition property of equality. I'm just going to ask if you agree or disagree with the equation that is revealed and take a moment to explain why or why not. So go ahead and press pause after the equation is revealed so you can decide whether you believe that it is in fact equal or unequal. So 5 is the same as or is equal to 5. Agree or disagree? Explain. (2.1) is plus 2.9 is equal to or the same as 5. Agree or disagree? And explain. 2.1 plus 2.9 plus 4/7 is the same or equal to 5 plus 4/7. Agree or disagree? Right now we're going to write a little bit about the addition property of equality. In words, what happens with the addition property of equality is if you take two equal quantities and add the same thing to both, the two quantities will remain equal. In symbols, what we're talking about, if a is equal to b, then a plus c is equal to b plus c. When we algebraically solve and check equations, there are basically 2 steps to algebraically solving and checking equations. First, we add opposites to both sides to zero out any non-variable term, and then check using the original equation. At this point, I will ask you to save some space, maybe about a half a page, for some in-class examples next time I see you, and move on to your 5-6 notes. Lesson 5-6 is very similar to 5-5. We are solving, this time not an equation, but an inequality. So we're going to start out with things that are unequal, and then we'll be starting out with things that are compared with an inequality rather than an equal, and they will remain unequal. So again, agree or disagree. I want you to write down any inequality that you see that you disagree with. So 3 is less than 10, -4 is greater than -7, -2 is less than or equal to 8, and 0 is greater than or equal to -9. Here we've modified each of the original inequalities just slightly. I'm wondering if you agree that they are still compared in the same way. So for example, if we have 3 plus negative 2, is that less than 10 plus negative 2? If we have 4 plus negative 1, is that greater than negative 7 plus negative 1? If we have negative 2 plus 5, is that less than or equal to 8 plus 5? And if we have 0 plus 6, is that greater than or equal to negative 9 plus 6? Remember, the inequality symbol, just like the equal sign, does not only pertain to this number, but actually the whole expression here. It pertains to the negative 9 plus 6, which is really negative 3. So each of these in our warm-up shows an example of adding the same quantity to both sides of an inequality. And the first one, when we added negative 2 to both sides, we ended up with 1 is less than 8, which is true. In the next one, we added negative 1 to both the negative 4 and the negative 7. We ended up with negative 5 is greater than negative 8, which is true. In the last one, we added 6 to both the 0 and the negative 9, and we were left with 6 is greater than or equal to negative 3, which is again true. And in this one here, we've added 5 to both the negative 2 and the 8, leaving us with the inequality 3 is less than or equal to 13, which is true. The inequality will always remain true as long as we add the same thing to both sides. This is the addition property of inequality. It says if A is less than B, if you have two quantities that are compared with an inequality, A is less than B, and you add the same thing to both sides, then A plus C is also less than B plus C. This would work if the inequality was rather than less than, greater than or equal to, less than or equal to, and also the not equal to inequality symbol. At this point, I'm just going to ask you to save, again, maybe about a half a sheet for some in-class examples, and you are done with today's notes.